Welcome once again to our lesson for today, and it's a great privilege coming your way with another lesson. Now, in our previous lesson, we actually looked at trigonometry, and we found out that we have some tools which is used to work on triangles, to measure the angles or to calculate the angles and also to calculate the sides. So we came up with Pythagoras theorem, which is used to connect the sides of a given right angle triangle, and then also the trig ratios, the basic ones. And the basic ones were three, which included the sine, the cosine ratio, as well as the tangent ratio. I made mention of the sec, the cosec, and then the cotangent, but I didn't give you the definitions for them. Today I'll be doing that. Okay, so this is the question I left you to try your hands on. So can you share your submissions with me? Then I can move on to today's activity. So we have three questions. Question number one, you are to actually find the missing letters. So question number one, we are to find the value of theta. We have to find the value of theta. So please, first submission, who is taking us through it? Who is taking us through it? Emanuela, can you do as the Anna? Taking us through. Then Abigail, you take the next. Then Francina, you take the next. Yes, I'm listening, please. I'm writing your solution in green. Yes, can you take us through, please?
To be honest, I couldn't do the work
Why?
because I didn't get a fair understanding after I even went back to the video again.
Oh,
So I was
okay.
hoping I could
Get
get
it.
more.
All right. No problem. Okay, then Abigail.
Sir,
Yes.
please, I was only able to solve the third one.
The third one. So the first one.
Yeah.
Okay, Francina, how about the first one? Can you take us through if you were also able to do it?
Sir,
Yes?
sir, please, I want to try.
Okay, give it a try.
So, I used the adjacent over hypotenuse.
Okay. You use the adjacent over the hypotenuse for this question.
Yes.
All right. Why did you use adjacent over the hypotenuse?
Sir, please, because we're given the hypotenuse and we're
Uh-huh.
given the adjacent.
Are you sure from this diagram?
Sir, sometimes I don't know how to divide. Is it opposite or is adjacent?
All right. It's supposed to be the opposite. Ideally, this question has a question mark on it.
Okay, sir.
Yes. So I
So
knew
it's the
that,
opposite.
yeah, it has a question mark on it for the fact that the hypotenuse always becomes the longest side of the right angle triangle. But unfortunately, the value found over there looks smaller than the other side. Are you with me? I think I
Yeah.
messed up the values. So I should have written the 5
Oh,
here and then the 4 over there because I was in a hurry.
yes, sir.
So ideally, this question is unsolvable for the fact that the value at the hypotenuse looks smaller than the other side, which is not supposed to be so.
Okay, sir.
So this question is unsolvable. But if I should change the values there and bring the 5 here and put the 4 there, the tool which is advisable to use to find the angle theta will automatically be the sine ratio. The sine ratio. Why the sine ratio? I told you that based on the trig ratios, the interior angle defines the side of the right angle triangle. So for instance, the side 4, remember I've changed the position. So let me clean the old ones. I'm cleaning the 5 from here and I'm cleaning the 4 from there, so that the question now reads perfectly as what we can see here. Please, are you with me? So this is how
Yes.
the question reads or should read. Therefore, with the new positioning of the 4 and then the 5, then it means this question is now solvable. For the fact that the 4 assumes the position of the opposite side to the angle theta. And then the 5 is automatically the hypotenuse because the right angle faces the side 5. Hence, we have to use sine because we know the opposite and we know the hypotenuse. And we are supposed to find the angle. So the sine ratio will be appropriate. So sine theta should be equal to the opposite side over the hypotenuse. So what do we have? We are looking for theta. So sine theta, then we substitute the values for opposite and hypotenuse. And what are they? 4 on 5. So finding theta, then you have to find the inverse of sine. So sine inverse will be 4 on 5. Kindly program on your calculator for me and tell me the value.
That is 6.9.
So 36.1 degree.
9.
9, sorry. So 36.9 degrees. So the value of theta, which will satisfy the positioning of the opposite and then the hypotenuse, is 36.9 degree.
Sir,
Yes, please.
please can you go over again? Like the
Okay.
part that we change the sine theta to sine inverse.
All right. It's like change of subject. If you have an operation of 2x equal to 4 and you want to find the value of x, what do?
Please come again.
You have operation like 2x is equal to 4 and you want to find the value of x. What must you do to get the value of
So we
x?
divide both sides by 2.
You divide both sides
Multiply
by
by
2.
2.
Good. The same way when it comes to operations involving sine theta equal to opposite over hypotenuse, if you want to get rid of the sine so that it will be left with the theta, you must find the inverse of the right hand side. It's like, again, you have x squared is equal to 9 and you want to find x. How can you get rid of the square?
You introduce a root.
So you introduce the square root sign on both sides. So the same way, if you have sine of an angle theta equal to opposite over hypotenuse and you want to find the theta alone, getting rid of the sine, you must find the inverse on the other side. So again, if you have cos of theta equal to adjacent over hypotenuse, and then you want to get rid of the cos, you must find the inverse of the other side.
Okay, sir.
So that is how the whole operation is obtained. Are we okay, please?
Yes.
All right. So let me clear this side, then we go through example number 2 or question number 2 that I left you with. So as I said, when it comes to right angle triangle, the position of the angle introduced inside the triangle defines the sides a lot. Can I move on?
Yes,
Therefore,
please.
with this right angle triangle drawn and with the value theta that we are looking for, automatically the right angle sign is defining the hypotenuse. So we know that our hypotenuse is already 5. But when you come to the value 3, looking at the position of the angle theta, the 3 and theta lie adjacent to each other. When we use the word adjacent, adjacent means side. Adjacent means side. So it lies on the adjacent side. So you are on the side of theta. So the position of 3 is adjacent. If we should have had a value here, then that value would have been directly opposite to theta. Please, are you with me? But we don't have any value here. So meaning that in this diagram, we only know the hypotenuse and the adjacent side. And since we know the hypotenuse and the adjacent side, and we are looking for the acute angle inside, then from our previous discussion, which two did we learn that it connects an acute angle, hypotenuse, and adjacent side of a right angle triangle? Which two did we say connects them?
Sir, please, the car, the
The,
cosine.
the cosine. Thank you. So that is the cosine ratio. So cosine ratio, or the cosine of the angle theta, should be equal to the adjacent side over the hypotenuse. So cosine theta should be equal to our adjacent value is 3. Our hypotenuse is 5. Therefore, getting theta, that will be equal to cos inverse of 3 on 5. And therefore, what is
Yes.
going, yes, please.
I thought the adjacent side is the horizontal one.
All right. The adjacent side is not the horizontal one. It is the angle, the position of the acute angle that determines which side is going to be opposite and which side is going to be adjacent. So from the position of the angle theta, as we see here, it tells us that the adjacent side is 3. That's why I placed this dot here. If there should have been a value here, then that value would have been opposite to the theta. Let's assume that you are standing at theta and I'm standing at the dot here. Then we'll be facing each other. So when we are facing each other, we are opposite to each other. Don't you think so?
Yes.
Yes. So it is the angle theta that determines which side is opposite and which side is what? Adjacent. So from this diagram, 3 is the adjacent side and the dot here is the opposite. So in the question, we know the adjacent side and then the hypotenuse. But from the first question, we knew the 4, and the 4 was directly opposite to the theta. And we knew the hypotenuse because the right angle faces the hypotenuse automatically. Are you okay now?
Yes, please.
All right. So please kindly operate this on your calculator for me. Cos inverse of 3 on 5. What answer are you getting?
53.1.
So we have 53.1 degree. And that is the angle that connects the ratio between 3 and 5. Yes, please.
Sir,
Please,
please,
the
the
first
first answer we got to
one.
was
Thank
53.13.
you.
and not 36.9.
No, please.
No.
All right, then let me clean it. Thank you for the correction. I appreciate it. So the first question is 53.1 degree. Thank you. Can we move on to the next?
Yes, please.
Now, the next question, actually, how many variables are we looking out for in this question?
3.
Sir, please, 2 or 3. 3.
There are three. So the first one is theta, the other is alpha, and the last is x.
X.
Let me copy it to a different page, then we actually solve it together from there. All right. So from whatever we have here, which variable would you have solved for first?
The the X.
The x value. Thank you. I believe the x value would have been the best to solve for first. Now, solving for x, what idea would you have used to solve for x, depending on the information that we know for now, which is 6, 9, and that is what you must use to get x. We would have used what?
Pythagoras.
The
Pythagoras
Pythagoras
theorem.
theory.
Thank you. So it means that the Pythagoras theorem would have stated as the hypotenuse squared, which is 9 squared, should be equal to the legs squared, the sum of the legs squared, so 6 squared plus x squared. Then making x the subject, then we regroup. So we are going to have 9 squared minus 6 squared equal to x squared. And that is going to give us an answer of x is equal to square root of, please operate this for me. That is 81 minus 36. What value are we getting? Square root of what?
45.
45.
45.
I believe 45.
6.3.
All right, it's giving us a decimal. So I wouldn't advise you to leave
Yeah.
the answer in a decimal form. But if you can leave the answer in a third form, that would have been perfect. So x is equal to 3 root of 5. Is it true?
Yes.
Good. So it's advisable to leave the answer in the third form and not the decimal form, most especially when it involves the sides. Unless maybe the question demands that leave it in the decimal form, then you can do so. The reason being that decimals or approximations actually causes so much harm. That is why it is always good to know your concept of sets. Now we found the value of x. We have no choice than to find the value of alpha or the value of theta. And therefore, getting the values of alpha and theta, we have no choice than to use the trig ratios, the basic trig ratios for that matter. Using them, you must know your positioning of the sides very well. Automatically, what have we found? The position of the 9 is assuming what?
The hypothesis.
The
So the
hypotenuse.
hypotenuse.
It's assuming the hypotenuse. Now, the 6 and then the x, which we've seen as 3 root 5, assumes different rows depending on the position of theta or alpha. If I connect or I want to find theta, the theta and x are what to each other?
Opposite.
They are opposite to each other.
The opposite.
But the theta and then the 6 are what to each other?
Adjacent.
So it means if you want to find theta and you want to use 6 and maybe 9, maybe the rule that you have to think of may change. Or if you want to use 6 and alpha and 9, the rule might change. So you should know what you are looking for and which position is assuming. So the 6 can assume adjacent when it comes to theta, and the 6 can assume opposite when it comes to alpha. Are you with me?
Yes.
All right. So now the decision is in your court. Which one would you find first?
Alpha.
Okay, so you want to find alpha. Finding alpha, it is always advisable to use the information that you already have in the diagram than to use a calculated value. Because if you use a calculated value and then the value is wrong, trust me, it means what you are going to calculate for is also going to be wrong. So you are going to get a double slap. But if you use the information which is already in the question to calculate for something new, perhaps you may get it right. Please, are you with me?
Yes.
All right. So finding alpha, knowing the 6, which is now assuming the opposite side to alpha, and 9, which is the hypotenuse, which trig ratio will be appropriate to connect opposite hypotenuse and the angle alpha?
Sir, please sign.
Sine. Good. So sine of alpha will be equal to 6 on 9. Therefore, alpha will be equal to what?
Sine inverse
Alpha
of
will be equal
6
to the
on
sine inverse.
6 on 9. Please work it out for me. What's the alpha value?
41.8. So when you round it up, you get 42.
So 41.8 degree. I will advise you just to write it
You
as
round it.
that. Yes, just write it as this.
Okay.
I wish you could have even written it to 4 decimal places, but you for now. Don't let us do premature approximations. Then again, we move on to getting theta. In getting theta, what can we do to find the value of theta? Because that's what is left.
Sir,
So you
please
can
can
use
you
the cosine.
We can use the cosine. Again, what else can we use?
You can also use the sine.
Are you sure?
That is if you want to use the calculated value.
All right, but I've advised not to use that. Yes, you can use either the sine or the cosine to get it done. Again, there's another way of still getting the value of theta. What else? Someone should get it right for Analiwa.
Hmm?
Yes, for Analiwa. Yes, who is getting it right for me?
So you can use a tangent because if you don't use the calculated value, you can't use a tangent.
Yes, I know. And I believe this one too will still use the calculated value, what I'm talking about. If you have a right angle triangle and you put alpha here, how can you also get theta?
So you can
So
use
you can
cos.
add the interior
Exactly. So
subtract.
you've gotten the aliwa. So you can add all the interior angles and then equate it to 180 degrees. So these are the
180.
various ways. But so
Yeah.
don't limit yourself. It cuts across. You should just understand everything and then use them as such. So as we said early on, if you don't want to use any of the calculated values and want to use something new to get the answer, in order to get theta with a position of 6 to theta, it's adjacent. And the 9 is automatically the hypotenuse. So we are going to have it as using the ratio of cos. Cos of theta will be equal to the adjacent side, which is 6 on 9. So theta will be equal to cos inverse of 6 on 9. And theta value will be what? Please, from your calculator.
48.1 degrees.
So 48.1 degree. Are you sure? Please confirm the answer.
Say it will be 48.189. But it's, I don't know whether you round it up or like you leave it in how many decimal
Okay,
points.
so you can just leave it as that. But remember, okay, so remember that, this is a right angle triangle. So as I said early on, you could have also said that 90 degrees plus theta plus alpha should be equal to 180 degrees. And you were looking out for theta and you knew alpha. So theta would be equal to 180 minus alpha, then minus 90. And theta will be equal to 180 minus my first idea, which is 41.8, then minus 90. And you have to get the same answer. Please, what answer are you going to get?
48.2.
So you had 48.2. 48.2. Now over here, so does it mean that your 41.8, was it short? I don't know if it was short.
We had 48.189.
Okay, 189. So if we could have written it to more decimal places, then we could have had like a perfect answer. So you realize that over here you are getting 48.2, over here you are getting 48.1. Was it 19 or 15? Can you tell me so that I can write it well?
48.1896851.
All right, then we should have written it as 48.2 degree so that
Yeah.
it pairs up rightly with this. So my
And
dear
say you
student,
know that you are because I said it.
all right, thank you. All right, so as we said, without using any calculated values, this is the right information we could have used to get the answers. But you could have also answered the same question rightly using a calculated value, but the operation would have changed. But as I said, if you get the calculated value wrong, it means you are going to be slapped twice. So let's know or take the right decision in actually using the tools. So just a recap of whatever we did in our last meeting. If you have a right angle triangle, this time I'm drawing it in the opposite direction. If we have a right angle triangle and then we have the sides labeled C, A, and B, and we have angles theta and alpha positioned. From Pythagoras, from Pythagoras theorem, from Pythagoras theorem, we are getting C squared is equal to A squared plus B squared. Are we okay with that?
Yes.
Then from the trig ratios concerning theta, A is opposite to theta, B is adjacent to theta. Therefore, if I want to find sine of theta, then it's going to be what ratio? Yes.
Opposite over
Oppo
hypotenuse.
yes, I'm just
Hey,
putting so it is going to be what letters?
say
Okay, let me
A
write it. Opposite over
over
hypotenuse. So
So
it's
A
going to
over
be
C.
A
no
over C. Then if I want to find cos of theta, it's supposed to be adjacent over hypotenuse, which is going to be B on C. If I want to find tan of theta, is supposed to be the opposite over the adjacent, which is going to be A on B. Are we okay?
Yes.
Then again, if I want to find alpha, if I want to connect alpha and then the sides, alpha and B this time around are rather opposite. Alpha and A are what?
Adjacent.
Adjacent. So it means that connecting alpha and the sides, if I want to find sine of alpha, that is going to give me the opposite side as B over the hypotenuse, which is C. And then the cos of alpha will be equal to the adjacent side A on C. And then tan of alpha will be equal to B on A. Are you all with me?
Yes, please.
So I believe those of us who were having doubts in our previous lesson, you understand the trig ratios and the Pythagoras theorem and how to connect them now.
Sir,
Yes,
please have a
please.
question.
I'm listening.
Please, you see, in the previous questions,
Yes.
you said we should find theta.
The
So,
missing values. Yes.
yes, please, does it mean that when finding um, theta, maybe in a question like what you gave us, is it the where the what's the name? The angle is being placed? Is that like where is that what would determine the opposite and the adjacent of
Exactly.
the
Exactly. So it's the
okay.
position of the angle that determines which side is opposite and which side is adjacent. Then you have to look out for them and then use them. That's all.
Sir, please, can you talk a little about the tan?
The tan ratio.
Yes. Yes.
The tan ratio is a ratio between the opposite side over the adjacent side. That is the definition of the tan ratio. So in a question, if a diagram is given as this, we'll be using it this time around so much, even though as at now, all the questions we are answering, we've not used tan. In our lesson for today, we'll be using tan a lot. But what's something here? If we were to decide to use a calculated value from this question, if we were to decide to use a calculated value from this question, we could have used tan to find out some of the values as well. For instance, let's take it that we're to find alpha, and then we knew the 6 and we knew the x value, for which x value was 3 root 5. Am I right? So alpha and 6 are opposite to each other. Alpha and
Yes.
x are adjacent to each other. So if I want to take a
Yes.
decision of using tan to find the alpha value, then it means tan of x, tan of alpha will be equal to the opposite side over the adjacent side. So what is the opposite side of alpha? It is 6. Out of what is the adjacent side of alpha? It is 3 root of 5. So how then do we get alpha? Alpha will be equal to what?
Tan inverse of 6 on 3 root 5.
So tan inverse of 6 on 3 root 5. Kindly program it on your calculator for me and tell me the alpha value.
The alpha value is 41.8.
41.8 degrees. Is it true
Yes.
that we had alpha as 41.8 degrees?
Yes.
So it means that is how the relationship lies between the sides of a right angle triangle and the corresponding interior angles. And trust me, you could have even used the x and then the 6 again to find theta, and you were still supposed to use tan to get the answer for theta if you were to decide that you are using a calculated value, which is right. So, my dear sister, as you were asking, the ratio of the opposite side of a right angle triangle over the hypotenuse, over the adjacent side gives you the tan of the angle. And that's how you apply it. So anytime you have a right angle triangle drawn, let's say like this, and then you have the legs rather known without the hypotenuse being known. The legs are A and B. And then you have, let's say, theta or let's say alpha. You don't have any choice than to use the tan ratio to connect them, because that's the time you need that tool to connect the sides. So tan of theta will be equal to, if I'm looking for theta and I know A and B, yes, opposite side of theta is what value?
It's B.
Divided by the adjacent side, which is A. Then again, tan of alpha from this diagram will be equal to what? Opposite side, which is what?
A on B.
A.
A
A.
on
B.
B. Please, are we all clear?
Yes, sir. So,
Very
please, I have
good.
a question.
Yes, I'm listening.
So, will you ever be asked to to solve for like how all this came about, like we did the other time?
You wouldn't be,
Like the
but
relationship between.
yes, they wouldn't ask you to show us how it came about. But trust me, as I said, if you know how it came about, when you are quoting it, it's easier to remember, right?
Yes, sir.
So just take it that, oh, I just came and I told you Pythagoras theorem came up with a formula which is c squared is equal to a squared plus b squared. Just that. And I didn't even show you
Okay.
how the explanations were. And then you just become someone who just chew things into your head, but you don't understand what you are doing. It makes it very difficult to remember. But if you understand how it came about, like when you are quoting it, you are happy and you do it freely. Remember, whenever you are writing any exams, it is what you know that determines how fast you are. If you don't understand the thing very well, you realize that you sit down and be looking into the skies, thinking that the answers will drop from the skies. And then you be having double minds as to, am I supposed to do this or am I supposed to do this? Am I right or am I wrong? You'll be doubting yourself. But if you understand what you are doing, you do it passionately and confidently, and you even finish it faster and move away from the paper. So it is always advisable to know how some of these things were brought on board and they relate, so that you can use some acronyms like so, ka, twa to remember some of these basic things. Not that I just quote so katwa. I say it, but you don't understand what so katwa means. I believe you can see the acronym here, what it means.
Yes.
What do you think the so means?
So I think sine of opposite over hypotenuse.
Exactly. So you see, I've not told you, but I've just given you an acronym, and then you can remember what it means. Please, are you all clear with what I'm doing?
Yes.
Sir, please, your
Yes.
question.
The last question, please.
Um,
Yes. Or you
sir,
have more than one.
I think no, this word like it just dropped into my head.
Okay.
Please, if you are given a question like just this triangular thing now, then in this section when you're supposed to find maybe theta,
Yes.
like in the right angle triangle,
Yeah.
then let's say you can use sine ratio like to find it, and you can also use maybe tan. I don't know if what I'm trying to say is making
Yeah,
some
I get.
sense.
It makes sense. Continue.
Ehen.
So it means you have
Like
two different methods in getting the same answer.
yes, is
Okay.
it like would they specify that use this one for this, or like you will choose your own choice, you
You
choose your
choose your method. Okay. You are not
choice.
limited as to what to use. All that it takes is that whatever method you are using is generating the right answer. Like what I said over here. Have you seen when we finish solving for theta? No, we finished solving for alpha. I said that what other way can we get the value of theta? And then we started bringing out some ideas like we can use the cos to get theta. And I said there's another form. And you started bringing ideas like, okay, if we want to use a calculated value, then we can use sine. And I said there's another way again. And then you said that we can use the sum of the interior angle of a given right angle triangle. So it means you have numerous alternatives to getting the same solution to a question. And you are not limited as to which one to use at what point in time. Please, are you okay?
Yes, please, thank
All right.
you.
You're welcome. So let's move on to another interesting thing today. As I said, from just our previous lesson, we looked at the relationship between right angle triangles with respect to their sides and respect to their interior angles. And you realize that the angles that we've calculated so far lies between 0 degrees, theta, and then 90 degrees. Have you realized that's where the angles lies between? You
Yes.
realize, yes, we've not had any angle beyond that. All the angles that we are reading lies between this range. So today we are going to look at the trig ratios, trigonometric ratio for special angles. Trigonometric ratio for special angles. Now the special angles we are considering, they are 30 degrees, 60 degrees, and then 45 degrees. Actually, I should have written the 45 in between the 60 and then the 30 because that's the next immediate smaller value after 30. But it doesn't matter. So we are working on this trig ratios for special angles like 30, 60, and 45. Even though your calculator can give you the answer straightforward and then like rightly, it is advisable to know them off head because sometimes the question may demand without using tables or calculator. You should be able to get to know them. So remember that how do we get these values straight ahead? Now, let me show you how these values were obtained, and that's how it got to be programmed on the calculator. We said trig ratios came from which diagram? Yes, trig ratios were generated from which diagram? Yes,
Triangles.
from a triangle. It was generated from a triangle, right angle triangle for that matter. But if I may ask, trigonometry is all about the study of triangles. And therefore, we have triangles beyond right angle triangles. Which special triangle would you get an angle of 60 degrees in it?
It's an equilateral triangle.
Thank you. That's so perfect. You have one Aliwa from me. So if we have an equilateral triangle, for which I believe you know the definition for an equilateral triangle. So let's assume this is my equilateral triangle. Pardon me if it doesn't look like equilateral triangle. So what's the definition for an equilateral triangle? In your own small way, what will you say?
It's a triangle. It has all the sizes to be equal and all the interior angles summing up to 180, which is 60, 60, 60.
All right, so we have this equal to that and also equal to that. And as you rightly said, each interior angle is 60 degrees each. Therefore, our 60 degrees idea is coming on board. All the sides are equal. So if all the sides are equal, then it means I can place some specific numbers there. So I can put 2 here, I can put 2 there, I have to put 2 there as well, because all sides are equal. I could have used any other number like 4. I could have used any other number like 3. But for the sake of we understanding the values for the special angles, that's why I'm using a number which I can easily divide through. All right. Now, I've not obtained any right angle triangle in it. So to obtain a right angle triangle in it, I'm going to introduce a perpendicular height. Introducing that, then it means I'm going to draw a line to partition it into 2 equal halves. In doing so, since the 2 sides here were equal, when I introduce a perpendicular height, it automatically also partitions the interior angle up here, which is 60, also into 2 equal halves. So what angle will we have here?
30 degrees.
30 degrees. And here it's equally 30 degrees. How about the base? It has also partitioned the base into 2 equal halves. So the dimension on the base was 2. Now it has been partitioned into 2 equal halves. So what do we have here?
1
And
and
then
1.
1. Thank you. So it means now I have a right angle triangle in it, and therefore I can find the trig ratios for these special angles like 30 degrees and 60 degrees. Because from one particular right angle triangle, I equally have the 30 degrees and then the 60 degrees in it. So let me copy that one and put it aside. So this time around, we have a right angle triangle for which we have informations like 2 here, we have 1 here, we have 60 degrees here, and we have 30 degrees here. What is missing? What is missing from this right angle triangle? Hello, what is missing from this right angle
I
triangle?
think I think we don't know the length of the perpendicular line.
Exactly, we don't know the length of the perpendicular line, which is either opposite to the 60 degrees or adjacent to the 30 degrees. Am I right?
Yes.
Can we label it as x?
Mm-hmm.
Okay, let's find the value of x. What idea can we use to find the value of x, please? What idea can we use to find the value of x based on the information there?
I can use Pythagoras theorem.
Perfect. That's what we must use to get the value of x. That's the easiest for now. So it means from Pythagoras
Sir,
theorem, yes, please.
please, no one is recording it.
Seriously,
Yes.
please do so. Even wherever we got into, please do so. Can we continue, please? All right, so going further, using the idea of Pythagoras theorem, then we are going to say that 2 squared must be equal to x squared plus 1 squared. And hence 4 is equal to s squared plus 1. S squared is equal to 4 minus 1. X is equal to square root of 3. Does it make sense?
Yes.
So my
Yes.
x value is root of 3 units. So now, watch and follow carefully. Watch and follow carefully. If I want to find the sine of 30 degrees, depending on the information there, sine goes with opposite and hypotenuse, right?
Yes.
What is the opposite value of 30 degrees from the diagram?
1.
1.
1.
So opposite is 1 divided by the hypotenuse. What value is it?
2.
So it tells you that directly and specifically, sine of 30 degrees is half. You can confirm it from your calculator. Can you confirm it, please?
This is true.
Good. Can we go for cos of 30? Cos of 30 degrees must be equal to the adjacent side divided by the hypotenuse. What is the adjacent value to 30 degrees?
It was x by
X.
root of 3.
It's what?
It was x by equals x is equal to root of 3, so it's
Yeah,
root of 3.
so root of 3 divided by the hypotenuse, which is 2. Can you confirm on your calculator that cos of 30 degrees is root 3 on 2? Yes. Confirmation, please.
Sir.
Yes.
Yes, please. Yes.
All
Cos
right.
of 30 is root 3 on 2.
Then we go to the last ratio, tan of 30 degrees. Tan of 30 degrees then will become the opposite side of 30 degrees, for which we've seen as the value as what? From the diagram. 1 on the adjacent side, which we've seen on the diagram as what?
Root 3.
Root 3. So tan 30 is 1 over root 3. But from the idea of sets, we can rationalize, isn't it?
Yes.
So when you rationalize root 3, you are going to end up multiplying the denominator by root 3 and the numerator also by root 3. So that is going to give you final answer as what?
Root 3 on 3.
Root 3 on 3. So can you confirm from your calculator that tan 30 is root 3 on 3?
Yes, please.
So these are the special angles. The first one is 30 degrees. The ratio of the special angle 30 degrees, these are the values that we've obtained. Sine of 30 is half. Cos of 30 is root 3 on 2. Tan of 30 is root 3 on 3. And your calculator can also confirm or testify to that.
Sir.
Yes.
Please, how do you get the degree sign on the calculator?
You cannot obtain the degree sign on the calculator, actually. This is not a programmable calculator, so you cannot obtain that one on it.
Okay.
Yes. Can we go to the next special angle, which is 60 degrees?
Yes,
So
please.
we are looking at sine of 60 degrees. We are still using the triangle as we have here. So sine of 60 degrees, depending on the position of 60 degrees, we must know the opposite side of 60 degrees. And what value do we have opposite to 60 degrees?
Root 3.
So that is going to give us root 3 on the hypotenuse, which is 2. So sine 60 is root 3 on 2. And your calculator can still confirm it. Can I move on?
Yes, please.
Then we go to cos of 60 degrees. Cos 60 degrees, concerning 60 degrees from this diagram, cos goes with the ratio of adjacent to hypotenuse. What's the adjacent value to 60 degrees? Adjacent to 60 degrees is what value?
1.
So that is going to be 1
1.
on the hypotenuse, which is 2. So cos 60 is half.
Is half.
Then last one is tan of 60 degrees. Tan of 60 degrees, we'll have to go with the opposite side of the 60 degrees within this triangle, which we've seen as root 3, divided by the adjacent side of 60 degrees, which we've seen as what value? 1.
1.
And root 3 over 1 is the same as root of 3. So can you
Root 3.
confirm your calculator that tan 60 is just root 3?
Yes, please.
All right. So my dear students, these are the trig ratios for the special angles 30 degrees and 60 degrees. It's left with one, which is the 45 degrees. So can we move on to 45 degrees?
Yes, please.
But I have questions for you. In as much as we are talking about from an equilateral triangle, we've obtained 60 degrees and then 30 degrees. Which triangle do you think we can obtain 45 degrees in it?
A right angle triangle.
Is it just an ordinary right angle triangle?
No.
But
In a
what?
right angle triangle, we have
Uh-huh.
a triangle with the bases equal.
With the bases equal. So which triangle has the bases to be equal?
A skeletal triangle.
Which one?
The skeletal triangle.
Skeletal. Where is that one
No,
coming from?
no. Sorry, the isosceles.
It's the isosceles. But you know, because we are dealing with a right angle triangle, then we are going to consider what we call isosceles right angle triangle. So it means it should be a right angle triangle though, but it should be isosceles as well. So two of the sides must be equal so that their base angle will also be equal. So we are taking it from isosceles right angled triangle. Hence, here must be 45 degrees and here must also be 45 degrees. Therefore, if that is 45 and that is 45, so the side here must be equal to the side there.
90.
The side here must be equal to the side there. Or the leg here must be equal to the leg there. So we can take it that the leg here is 1. The leg here is also 1. You can use any other number at all. But just using numbers that can make it easier for you to manipulate the values. And hence, we know 1 as the value of the side here, 1 also there. What don't we know from the right angle triangle now?
The hypotenuse.
We don't know the hypotenuse. So can we label the hypotenuse as C? And if we
Yes.
do so, how can we find the value of C?
Pythagoras.
So using Pythagoras theorem.
Sir,
Yes, please.
sir, please can you finish drawing the diagram?
Yes, I've finished drawing it too. And I've
On my
placed,
screen, it's not done.
please, who else is also having a challenge of a frozen screen?
It's not frozen, but it's slow.
It's slow.
It's still drawing.
I guess it's the
Yes.
network. Maybe it might be the network. All right, so we are finding the value of the hypotenuse side, which is the C. So you said we should use the idea of Pythagoras theorem. So C squared must be equal to 1 squared plus another 1 squared. That's Pythagoras theorem. The sum of the square of the two legs should be equal to the square of the hypotenuse. Therefore, C will be equal to square root of 1 squared is 1 plus another 1 squared is also 1. So we have in final answer C as square root of 2. So C is square root of 2. Can we continue? Therefore,
Yes.
we can find sine of 45 degrees. Remember, the 45 degrees finds itself everywhere. So we can either use the 45 degrees here or the 45 degrees there. It's still going to give us the same answer. So if we consider any of the 45 degrees, what is the opposite side of 45 degrees? What value do we have there?
1.
1. Divided by the hypotenuse, what value do we have there?
Root of 2.
Root of 2. So can we go further to rationalize?
It will be root of 2 on 2.
Root of 2 on 2. So sine of 45 degrees is root 2 on 2. Can you confirm it from your calculator?
Yes, please. It's 2 on 2.
Okay, that's perfect. Then when we come to cos of 45 degrees, what is it also giving us? Adjacent side of any of the 45 degrees. Yes, if I'm considering this, what's the adjacent value?
1.
1 on the hypotenuse, which is root of 2. So what will be the final answer if we rationalize?
Root of 2 on 2.
On 2. Thank you. Then the final one is the tan of 45 degrees. So remember, sine 45 root 2 on 2, cos 45 root 2 on 2. Can't you easily remember this? I
You're
believe,
supposed to remember.
yes, you have to remember. So, because I have told you, what you know determines how fast you are. So that you don't always depend on like the calculator. If you know it off head, yes, it will help you because it will make you faster in your presentation. Are you okay?
Yes, please.
All right.
Sir,
Yes, please.
so they give us a question based.
You'll be seeing some of them very soon. Don't worry. You'll see some of them very soon. All right. So we are on tan of 45. Therefore, the ratio of tan is opposite on adjacent. So what's the opposite value of 45? 1. Adjacent value of 45.
1.
1 on 1 is the same as 1. So tan
1.
45 is 1. Are you okay?
Yes.
Good. So they can just ask you, some of you might be with even the science and math quiz and they ask tan 45 is 1. True or false? You should be able to know that. And it's true, right?
Yes.
Okay. You didn't use a calculator to do that. You actually have it clear. Are we okay? So that I move on to the next. I'm going to add more, so please follow me carefully. But if you have any question, kindly ask before I move forward. Because now I'm done with the trig ratio for the special angles. What I'm going to consider right now is trigonometric ratio for general angles. Trigonometric ratio for general angles. That's my next subtopic. So considering the trigonometric ratio for general angles. General angles. So when we consider general angles, there are angles that goes beyond 90 degrees. So we are looking at from 0 degrees all the way to 360 degrees. It can go beyond, but we are limiting ourselves within this range. So this is a complete circle, right?
Yes.
To make it easier for your understanding, when it comes to trigonometric ratios or trig in general, trig angles are measured from the positive x-axis in the anti-clockwise direction. Watch what I'm doing carefully. Trig angles are measured from the positive x-axis in the anti-clockwise direction, and that gives you positive angles. I'll be explaining that. So when you measure trig angles from the positive x-axis in the clockwise direction, they give you what we call negative angles. So don't confuse bearing with trig angles measurement. Unlike bearing, whereby you must always measure it from the geographical North Pole in the clockwise direction, when it comes to trig, the angles are measured from the positive x-axis in the anti-clockwise direction. Please, am I clear?
Yes, please.
So always the angles in trig are linked up with the positive with the x-axis. They are linked up with the x-axis, and because of that, it makes, how many quadrants do we have in this Cartesian plane?
Four.
We have 4. So it means since we are measuring from the positive x-axis in the anti-clockwise direction, it makes the naming of the quadrant system to be in the anti-clockwise direction. So we have first quadrant, second quadrant, third quadrant, and then the fourth quadrant. And interestingly, the behavior of all the trig ratios looks different within the quadrant system. And the basic trig ratios are sine, cosine, and then tangent. The other trig ratios, which are the cot, sec, and cosec, I'll be talking about it, but when we launch into the deep of trig, that is when I'll bring them on board. That's where we'll be learning something about identities of the trig ratios. That's when they will come clearly, and that's more of the details of elective. The surface so far is more of core, but when we launch into the deep of trig, trust me, that's where the other ones will be coming. those names sec, cosec, and then cotangent. But it's nothing difficult. You really understand it. So as I said, the trig ratios behave differently within each quadrant system. And from what we've learned so far concerning the trig ratios of special angles, that is going to help us understand the trig ratios for general angles. Any question on what I've said so far before I move on? No question. If I may ask, why is it that trig ratios are measured in the anti-clockwise direction and then bearing is measured from the geographical North Pole? What will you say? Yes, why is it so?
Yeah, I think the trig ratio, when
Mm-hmm.
you start from the north, the geographical, the origin is not a negative and it's not a positive too.
Mm-hmm.
So when you measure from that angle, you won't be able to tell whether it's a positive angle or a negative angle.
Oh, okay. Any other? That's good. I really like your submission. Any other? Okay, it's all because of the movement of the earth. It's coming from the nature of movement of earth. So, earth movement. Do you know that the earth moves in different directions?
Yes.
Okay, can you tell me much about it? We have what we call rotation
A revolution.
of earth, and then we have revolution of earth. I know some of you do geography. I know some of you do that. Okay, rotation of the earth brings about what?
Day and night.
So
The
this leads
movement
you
of
to
the earth and
day
its orbit.
and night. And then revolution of the earth brings about what?
Seasons.
Seasons or the seasonal changes. How does the rotation of the earth takes place? Yes. How does the rotate? It brings about day and night. So how does it take place? Does it move in the clockwise direction or anti-clockwise direction?
So the earth, yes, the earth moves on its own axis
Yes.
in an
I-
anti-clockwise direction. So the part that faces the sun will experience day, whilst the other part that is not facing the sun experiences night.
Yes. But how about the revolution?
The revolution is the movement of the earth around the sun.
Yes. And it's done in what direction?
It is done in an anti-clockwise direction.
Good. So revolution of the earth goes in the anti-clockwise direction around the sun. Around the sun. And then rotation goes in the clockwise direction on the earth's own axis. Please, are you with me?
Yes.
So the earth spins on its own axis in the clockwise direction on its own axis, whilst it revolutes around the sun in the anti-clockwise direction. Have you ever thought why whenever you stand and let's say you are spinning yourself and you stop, what do you realize?
You feel dizzy.
You feel dizzy. It's like the earth is going whether clockwise or anti-clockwise direction. And actually, God in his own wisdom made this possible for the fact that it stabilizes all activities on the earth. I hope you know that we are living on the surface of the earth, and the earth itself is even hanging.
Yes.
And we have water bodies on the earth, but you don't see these water bodies dropping. We are in space, actually. We are hanging, but we are standing on the earth. And it will interest you to know that we get stuck on the earth for the fact that we are too small to fall off the earth. It's like you putting an ant on, let's say, a ball or in a basin, and then you start spinning the ball. Trust me, the ball that is spinning, irrespective of how fast the ball spins, the ant which finds itself on the ball is stuck. It will never move. Like, it will just move around freely as if nothing is at stake. Please, are you with me?
Yes, please.
So due to these concepts over here, the idea of trigonometric ratios and bearing ideas came on board. So please remember, trig ratios, their angles are measured from the positive x-axis in the anti-clockwise direction, whilst when it comes to bearing angles or directions are read from the geographical north pole in the clockwise direction. And for trig ratios, whenever you read any angle from the positive x-axis in the clockwise direction, it gives you what we call negative angles. And when you read it in the anti-clockwise direction, it gives you what we call positive angles. Please, am I clear?
Yes.
Good. If you have any question, you may ask before I move on, please. It's very important. So as I said, we are looking at the trig ratios of general angles. So we are going beyond 90 degrees. We are going beyond 90 degrees. Now, watch something here carefully. I'm first going to consider the quadrant system in the the trig ratios in the first quadrant. I'm looking at trig ratios in the first quadrant, and specifically trig ratios in the first quadrant lies between 0 degrees, less than theta, and less than 90 degrees. They are the values of trig ratios or the angles within the first quadrant. So first quadrant. Sometimes you, in the question, you realize that they will put this interval there. Immediately the interval displays, you should know which quadrant you are working in. So we have our x here, we have our y there. We have our x here, we have our y there. But remember, all values on the other side of x, they are negative. All values on the other side of y, they are also negative. So if you have any terminal line drawn in the quadrant system, so I have this terminal line here, and it happens that I introduce an angle here. The angle is theta. The angle is theta. Now, if I don't know the hypotenuse, and I actually know my so the right angle has been introduced towards the positive x-axis or towards the x-axis. Now, what will be the dimension of, or what type of y value would we have on the vertical axis here? What type of y value are we going to have? Is it going to be positive or negative?
It's going to be positive.
It's going to be a positive number. So that is going to be positive y because that's a vertical axis. How about the horizontal axis? What do you think will be the s value? What type of value is it going to be?
Positive.
It's also going to be positive. So that is going to be x. So if I place r here as my hypotenuse, then connecting them let's watch the behavior of the trig ratio, please. Let's watch it. I beg you, watch it carefully. Remember, we are dealing in the first quadrant. What will be sine of theta from the dimension here? Sine of theta is going to be opposite value, which is what value?
Y.
Y over the hypotenuse, R.
Hypotenuse.
Are you okay?
Yes.
And it's going to be a positive number over another positive number. So it means sine ratio in the first quadrant is automatically positive. So whether if, yes, please.
Please, I have a question.
Yes, I'm listening.
Please, is the hypotenuse always a positive number?
The hypotenuse is always a positive number. We'll verify it very soon as we go along. So you see it. Again, cos of theta, based on what we have here. Cos is adjacent side. What's the adjacent value there? From the diagram, x over the hypotenuse, which is r. So it's a positive number over another positive number. Therefore, cos of theta is going to be a positive number in the first quadrant. Then we go finally to tan of theta in the first quadrant. So tan of theta is going to give us opposite side as x, and then sorry, y on x rather, right?
Adjacent.
It is
No, it's adjacent.
it's
Opposite
y.
over adjacent.
Yeah, so opposite side to
So y
theta.
on x.
Yeah, so y on x. And it's positive y over positive x. So it means the tan ratio for any angle in the first quadrant is automatically a positive number. Can I move on?
Yes, please.
All right. Let us take, or let's confirm these things with our calculator. So right now we found out that if I have 30 degrees or 60 degrees, whatever the angle may be, any angle that lies within 0 degrees and 90 degrees, it means it lies in the first quadrant. So the answer it needs to give me must be a positive number automatically. So we've already found sine 30. We found cos 30. We found tan 30. They are special angles. And we realize that all these values were positive numbers. Am I right?
Yes, please.
Sine 30 was seen as what? What's the answer for sine 30? Yes, what's the value of sine 30?
Sine 30 was 1 out of 2.
So we had sine 30 as half, cos 30 was root 3 on 2, and tan 30 was what? Root 3 on 3. Do you see that all of them are positive numbers?
Yes, please.
So it confirms that in the first quadrant, all the trig ratios are positive. All the trig ratios are positive in the first quadrant. I'm done with first quadrant. The behavior of all the trig ratios in the first quadrant, they are positive. Can I move on? So whether it is 45 or 60, whatever answer you are going to get is going to be a positive number. Can I move on?
Yes.
Going to the second quadrant. So I'm in the second quadrant. Second quadrant. In the second quadrant, Then we are looking at angles between 90 degrees, less than theta, and less than 180 degrees. Does it make sense? So we are here. I have my y value here. I have my x value there. Negative y here, negative x there. Then my terminal line must be shown in the second quadrant. But remember, the general angle that I need to measure must come all the way from the x, positive x, in the from the positive x until it meets the terminal line. I hope I'm right.
Say,
Yes.
please, I can't see the screen.
Who else cannot see my screen, please? Please, who else cannot see my screen? Because this one I'll be ending the lesson. Who else can see the screen, please? Hello.
We are only three. Okay, so I can see now.
All right. This is the last one. In our next meeting, I'll continue with what we're studying. So now we move on to the second quadrant. Remember, our general angle must be read from the positive x-axis in the anti-clockwise direction to meet the terminal line. Okay. Now, when we connect the terminal line here, I'm just making it very easy for you. We must introduce our right angle towards the x-axis. So if I draw my right angle towards the x-axis, it means I'm going to have it here. That's my 90 degrees. What will be the dimension of the x value, the vertical axis here? What value is it going to be?
A negative.
A negative number. Are you sure? Vertical axis.
Positive value.
It's a positive y. What will be the value of the x on the horizontal axis?
Negative.
Negative x. That's what we are going to obtain there. So watch something here. Since I introduced the right angle towards the positive x, the x-axis, it means my angle reading should be here. The angle reading should be here, and that will be equivalent to the angle reading generally. So it means I have an angle theta here. If I want to find sine of theta based on the diagram here and the dimensions that I've placed on it, remember here is r. R for the fact that it's going to be a positive number all the time. Someone asked that question. So if I'm using Pythagoras theorem, r squared is equal to y squared plus negative x all squared. So r will be equal to square root of y squared plus x squared. I hope it's clear. So r value is always going to be a positive number. But the opposite and adjacent may change because of the position of the terminal line. What will be sine theta from the diagram here? From the diagram here, what will be sine theta based on the
It will be y out of r.
y out of r? It's a positive number, right?
Yes.
How about cos of theta? What is it also going to generate?
Negative x on r.
On r. Which means if you have a fraction whereby a negative sign is affecting it, it means the whole fraction is negative, right?
Yes.
So it means cos is negative within the second quadrant automatically. Tan of theta will be equal to what?
Y on negative x. So negative y on x.
Exactly. So it means that tan of theta is also going to be a negative value automatically. So if I may ask, how do I find the general reading of this angle from the x, positive x-axis? What do you think will be the value here? If here is theta, what do you think will be the value here?
As in, we are finding the angle of
Yes, what
the
will be
red
the
part.
red part? The red part. What will be the angle there?
So if we know what theta is,
Yes.
we can subtract theta from 180 to get that part.
Exactly. So it means the red part angle found over there is 180 minus theta. 180 minus theta. But at the end of the day, what I want you to establish here is that all the trig ratios, any angle that lies in the second quadrant, if you find sine of that angle, automatically it's going to give you a positive value. But when you find cos or tan of that angle, it will automatically give you a negative angle. Let us verify that and then run away. In our next meeting, we'll continue. Now, what are some of the angles that we can obtain in the second quadrant? If we assume that here is 30 degrees, it means some of the possible angle or one possible angle will be 150 degrees. Do you agree?
Yes.
So 150 degrees is possible to be in that quadrant. We can equally have, if we have x as 60 degrees, then it means 120 degrees is going to be a possible special angle in that quadrant. If you have it as 45 degrees, then what are we going to have at? Yes, generally to be what angle? That would be 135 degrees. Find sine of 150 degrees for me, please. Punch it fast, fast, fast. Just be fast on it.
It's half.
It's half. So it tells you that sine 150 is the same as sine of 30 in the second quadrant. And it's a positive number. Again, sine of 60 degrees. Punch it. Sine of 120 degrees in the second quadrant. Program it. It's root 3.
Of what?
Sine of 120 degrees.
Root 3 on 2.
Root 3 on 2.
So it is the same as sine of 60 degrees. So root 3 on 2. This is half. Sine of 135 degrees. Program that. Yes.
Root 2 on 2.
It is the same as sine of 45 degrees, which is root 2 on 2. All of them are positive. But let us see something here. Cos of 150 degrees.
Negative root 3 on 2.
Negative root 3 on 2. So in other words, cos of 150 degrees is the same as negative of cos of 60 degrees. Do you agree? Because cos 60 itself is negative, is root 3 on 2, isn't it?
Yes.
And therefore, when you negate it, it gives you the same value. So do you realize that the 150 degrees is an angle which is in the second quadrant? And therefore, what type of value are we obtaining for cos?
A negative value.
And does it confirm what we've written here? Does it confirm?
Yes.
Again, tan of 150 degrees, it's also going to give you a negative answer.
Negative 3 on 3.
So negative
root 3 on
root
3.
3 on 3.
Sir,
Yes.
please, I don't understand the part that the y is positive and the negative, the x is negative. Like how to determine.
When it comes to the diagram here, remember your quadrant system. If you label your quadrant system, y is above, positive y is above x, negative y is below x-axis. So if you've drawn your right angle triangle and then it is linked with the x-axis, vertical axis, remember there's the x-axis. So any line or perpendicular to it, line above it is going to be a positive of y. If we come
Yeah.
below it, that's when it's going to be negative of y because it comes in the negatives of y. Please, are you okay now?
Yes, please.
All right. Thank you so much for joining the lesson. It's a great privilege coming your way. I'll be sending you some notes so that you also read along whilst we move on. Today we've talked about the trig ratios for special angles, and then we've actually looked at the behavior of the trig ratios for just the first quadrant and then the second quadrant. We'll continue another time. Thank you so
Yeah.
much, and then keep on supporting my YouTube channel. I really appreciate it.
You're welcome.
All right. Have a nice day. Bye bye.
You too.
Bye.